if you realize how many people die of influenza every year, so for sure there is need for better vaccines to protect against this disease. And this is just seasonal influenza. So just imagine pandemic outbreaks for influenza, the mortality rates are much higher. Because we will have new pandemics. It's not a matter if, but when. My name is Guus Rimmelzwaan. I'm a medical biologist by training, and I've specialized in immunovirology over the last 32 years.
For more than 20 years, Guus Rimmelzwaan has been doing research into influenza viruses at the Erasmus Medical Center in Rotterdam.
Influenza viruses are amazing. I mean, these are really special viruses. So they're highly successful. They can escape immunity that has been induced by previous infections. And that is of great interest. It's also a big problem because it's very difficult to make vaccines against these viruses because you have to adjust the vaccines almost every year.
In addition, influenza viruses can be transmitted from animals to people and vice versa. So new influenza strains can develop which can cause a widespread epidemic.
My main interest is how immunity to these different strains of influenza and to different subtypes of influenza A viruses coming from animals works.
Rimmelzwaan has discovered what important roles can be played by cytotoxic T cells in fighting influenza viruses. Influenza viruses are especially liable to mutate, a new variant every season. That is the special challenge. There are two defense mechanisms in the adaptive immune response, antibodies and T cells. Antibodies are directed at a specific surface protein of a virus type and so cannot normally recognize the virus of a new subtype. T cells, on the other hand, recognize certain invariable proteins which show themselves on the surface of infected cells, so-called preserved proteins. Because of the similar structure of the preserved proteins when infected by virus 1 or 2, T cells are able to render both infected cells harmless. What is more, they can quickly fight new variants of influenza viruses.
So we do a lot of experiments under these conditions to see what the impact is of T cell immunity on virus replication.
Rimmelzwaan wishes to find out how the immunity triggered off in humans reacts with viruses deriving from animals.
So I think that's important that you not only look at these viruses from the human medicine side or just from the veterinary medicine side, but to look at it from a One Health perspective.
The eye for the total view, precision and consistency. That fascinates Guus Rimmelzwaan. Also when he is on the golf course enjoying the few hours of leisure he has.
Well, if you hit it really well, it's really good. It's more a mental game than anything else. So you have to be concentrated, and your technique should be perfect. It's not about power; it's just about technique and concentration.
Things you also need to become a world-class virologist. Hanover will be the next step in his career. The veterinary university is well prepared to receive the professor. The Research Center for Emerging Infections and Zoonoses, or RIZ for short, is the perfect location for him to do research at the interface of human and veterinary medicine.
Well, first of all, it's a big honor to obtain this prize and this professorship. It offers a lot of opportunities that were not available in Rotterdam. I can set up a whole new research team that is completely dedicated on research in the field of immunity to influenza and other viruses. So that's really a big plus. And in addition, the RITS also have the possibility to do large-scale animal experiments. So Theo has invested in a large animal facility where we can work with highly pathogenic viruses.
with new colleagues in a new environment.
I would like to introduce our new Alexander von Humboldt-Professor.
All right, so my name is Guus Rimmelzwaan. I'm a prize winner of the Alexander. And obtaining the Alexander von Humboldt-Professorship with a substantial amount of funding will help progressing this research tremendously. And so the coming years I will learn a lot about immunity to influenza viruses and potentially also of immunity to other viruses.
So as to be better prepared for the next epidemic, and perhaps at some time or other to come closer to the holy grail of immune virology, the universal influenza vaccine.